Question 1. Scores on a test have a mean of 70 and a standard deviation of 12. Michelle has a score of 82. Convert Michelle's score to a z-score. Z is x minus the mean divided by the standard deviation, where x is the data value that we are going to convert. In this problem, we're going to convert Michelle's score of 82. The mean is 70, and the standard deviation is 12. 82 minus 70 is 12, and divided by 12 is 1. The value 82 as a z-value is 1. Question 3. The mean of a data set is 154.02, and its standard deviation is 87.27. Find the z-score for a value of 319.42. Z is x minus the mean divided by the standard deviation. We're going to convert the value of 319.42. The mean is 154.02, and the standard deviation is 87.27. The value is what we see in this calculator. If we approximate this answer to the nearest hundredths, the 9 is in the hundredth position. We look to the right and it's a 5. That means add 1 to the 9, so the answer is 1.90. Question 5. In question 5, we're going to compare two z-values to see which one is higher, because they're asking for the higher relative position. So z is x minus the mean divided by the standard deviation. Which is better, a score of 92 on a test with a mean of 71 with a standard deviation of 15, or a score of 688 minus the mean of 493 divided by the standard deviation, which is 150. We're going to have two z-values to compare. So the first scenario has a z-value of 1.4, and the second has a z-value of 1.3. The answer is 1.4. Question 7. Comparing z-scores. We're going to use z is x minus the mean divided by the standard deviation. Which score has a better relative position? A score of 252 on a test for which the mean is 240 and the standard deviation is 24, or a test in which the score is 62.4 and the mean is 60 with a standard deviation of 6. First C-score is 0.5. Second score is 0.4. The 0.5 is further away from the mean than 0.4. Question 9. The percentile of a data value x. That's defined to be the number of data values that are less than x divided by n times 100. So if we look at our data set here, what we want to do is sort the data from smallest to largest. We'll find that there are 3 data values that are less than 54 out of a total number of 7 data values. Three divided by 7 times 100. We're going to round or approximate this answer to the nearest whole number. So 42.857, and we look at the digit in the 10th position. It's an 8. We add 1 to the 2. Our answer is 43. This is the 43rd percentile. Question 11. We're going to use the same definition to determine the percentile of the data point 126. So we take our data, and we're going to sort our data from smallest to largest. So, the data point of 126, there are 12 data values out of 16 that are less than 126. 12 divided by 16 times 100. The answer is 75. This is the 75th percentile. Question 13. We're going to determine the first quartile, which is also the 25th percentile. In order to determine the 25th percentile, we need the locator. That's defined to be k over 100 times n. We need to know, since the value of k here is 25 divided by 100, we need to determine the number of data for question 13. Notice that this data is already sorted. They were nice to us in the problem. So let's find out the total number of data that we have in this list. There are 30 data values. Seven 7.5. Remember, if the locator is a non-whole number or a decimal, we round this value up. We round up, not off. Happens to be the same value as if we rounded off, which is the value 8. So if we locate the 8th value in the sorted list, right here, the answer is 6.4. That is, Q1 is 6.4, the first quartile, also the 25th percentile. Question 15. We are now asked to determine the 85th percentile. Once again, we're going to use the locator formula. And in this case, k is the value of 85. We need the total number of data in our list, the value of n, for question 15. Once again, they gave us a sorted data list. They were very nice to us. There are 40 data values in this problem. The answer is 34. This is a whole number. So what we need to determine is the 34th and 35th data value in the sorted list. If we look at our sorted list, 85 and 89 are the 34th and the 35th data value in the sorted list. We need to determine the value that is midpoint between 85 and 89. Those two values. The answer is 87. 87 is the value that represents the 85th percentile.